Earth Science students, this is Mrs. Gibbs, and I'm going to help you with 4.16 on plates and structural geography. So before we get to the worksheet, let's review a little bit about rocks. And we know that these plates on the surface of the Earth are constantly shifting and constantly moving. And we have three different types of plate boundaries. So let's take a look at those on the next page, I believe. So first of all, we have a compression, rocks moving toward each other, and this is happening at plates that are converging, so at convergent plate boundaries. So they would compress against each other. They're squeezing the rocks in the crust. Tension happens at divergent plate boundaries where you're pulling apart, okay? Tension, pulling apart, to stretch or to pull. And then shear forces happen at transform plate boundaries where we have these rocks that are moving past each other. Okay, and so you get a simple bend or break in these rocks. So let's look at what that looks like in a fault. So a fault is a crack in the rock, and depending on if the rocks are being pushed together or pulled apart or sliding past each other, that will change what the fault looks like. So on your screen here, you see a normal fault. And a normal fault, first of all, the rocks don't usually split straight like this, okay? They split this way or this way, okay? But they split at an angle. So if you're looking at a fault and you can see on the screen that this part that's shifted down is higher than the part that's this way, okay? This is a normal fault. So the one on the bottom is called a footwall because it is closer to vertical or closer to horizontal. Okay, if you were to stand like a miner on this, you could stand on this one. So this is a footwall, whereas this rock, you can't stand on it, right? This is where your head would be. So we call this a hanging wall because it would be over your head. So footwall, you could stand on if you're a miner. Hanging wall goes over your head. So if the footwall is higher than the hanging wall, this is a normal fault. On the other hand, let's go to the next page. We'll get to the next one. Okay. So on the other hand, if the footwall, which again is the one you could stand on, if it's lower than the hanging wall, this is a reverse fault. And so you can see the picture on the screen here. You could be able to stand closer on this rock here. The hanging rock, which is again tipping over you if you were standing in between these two rocks, this is hanging. So if the hanging wall is higher, like it is here, this is a reverse fault. And this forms when there is compression. So let's click on the answer there. So compression or convergent plates. So moving toward each other, you get a hanging wall that is higher. This is a reverse fault. Okay, I know this one kind of seems like it should be the other way, but a reverse fault moves toward each other and the hanging wall is higher. With a normal fault, we call this normal because usually you think of a crack happening if things are separating, right? So a normal fault is when plates are moving away from each other. This is happening at divergent plate boundaries. And in this case, the hanging wall, see how this one is tipped forward, hanging wall, it is actually lower than the footwall. Okay, so this is a normal fault. And this happens when plates are diverging, moving away from each other. So this is tension happening. And then strike slip faults happen at transform plate boundaries where they're just sliding past each other, okay, like this way or this way. And that shifts the rock's position. So let's open the assignment and we'll look at it together. Okay, so the first part you just need to color the rocks, and this is so that you can see it better. I'm not going to take off points if you can't print this one out because the coloring is helping you, but I'm not going to take off points if you can't print it and are just using the Word document, so that's fine. But you can see there's two faults. One is here, one is here. In this case, the layers appear to be lower than this one, and over here, these layers appear to be higher than this one. Okay. So question number 2, sediments are almost always deposited in flat layers. So do these layers look flat is your clue here. So does it appear that forces in the earth have affected the rock layers in this region? What clues do you have? So write a couple sentences. These don't look horizontal, do they? They don't look like they're in flat layers. So that would give you a clue that there have been forces at work. Okay, question 3, did pushing, which is compression, or pulling, which is tension, or sideways force, which is shear, in the rock layers produce folds and faults? So let's look at both of them. So up here, this is the, which one is the hanging wall? This is the hanging wall, right? The left side. And the layers are lower. So if the hanging wall is lower, what does that indicate? The hanging wall is lower, it indicates that they were pulled, right? So that's tension. If we're looking over here, the hanging wall is higher. So that indicates compression. So depending on which side you're looking at, both of them probably occurred. And then for, oh wait, yep, that was 2 and 3. Okay. For 4 and 5, we're going to look at actual pictures in the lesson. So let's keep going here. Okay, so here is some rocks, and I can't remember where they said it is located. It said on the worksheet. Where is it? British Columbia. Okay, so take a look at those for a second. The hanging wall is this side. The footwall is over here, because if you were in between these faults, you'd be able to stand on this layer, not this one, right? So this is the foothold. This is the hanging hold. So what can you tell? Look at how the rocks are lining up. Over here, it looks like the foothold is higher than the hanging hold. Okay, so this is the hanging wall, this is the footwall. So if the footwall is higher, that gives you a clue that what happened? They're being pulled apart, So if they're being pulled apart, what type of fault is that? I'm going to let you check. But do you see how, in this case, the footwall is higher? This layer in the footwall is higher than the corresponding layer in the hanging wall. So they are being pulled apart. This is tension. So what type of fault is this? Is that reverse, normal, or strike slip? So pause, go back and look. If the footwall is higher, what kind of fault is it? Next example, where is this one located? Klamath Falls, Oregon. Same thing. Okay, we have a fault here. Take a look, see if you can figure out what's higher. Is it the hanging wall or the footwall? What's higher? This one might be kind of difficult because we just have these alternating layers. But to me, it looks like this layer would match up with this one, and this layer matches up with this one. So for me, let me match this up for you. Okay, it's opposite from what I'm doing, okay? So it looks like the hanging wall is higher, right? The hanging wall looks higher to me. So if the hanging wall is higher than the footwall, what's going on? The hanging wall is higher. Are they being pushed together or pulled apart? The hanging wall is higher. Are they being compressed? Or are they under tension? and then what type of fault is it? So hopefully that gives you some clues as to how to complete this. I gave you some clues for these examples, but you still need to go back and determine for sure what type of fault it is. Have a great day, everyone.